Good afternoon again, students. Welcome to our new lesson today, and we're still talking about functions. Right, yesterday we introduced functions, and at least we now have a gist of what functions are. Right, we said they are expressions, but they are expressions that are mapped from one expression from a domain to a range. So that's what we spoke about yesterday. We gave an example, and we gave an example of how the functions are written. We gave the 4 types of mappings, which is a one-to-one, many-to-one, one-to-many, and a many-to-many. And we also spoke about which of the 4 mappings functions. So we said only a function is an expression that produces only unique values in the output, the values. So that's what we spoke about yesterday. So today we'll continue. Today we spoke about the inverse of a function. Then we'll get to know what type of functions do we have. We have linear functions, we have exponential functions, and we have quadratic functions that we still want to know about. But we're going to try to first get the concept, then we'll work with these concepts in the different sections of these functions, which I've just said that they are linear functions. Then we have continuous functions. Then we have exponential functions. We have quadratic functions. We have so many functions, but at our level, those are the only functions that we are required to know that will be set in our exam. So without wasting much time, let's get to our lesson. So today we'll talk about functions. So today we want to speak about the inverse. We want to speak about the inverse of a function. If we say inverse of a function, what do we mean if we say an inverse of a function? Right. So remember yesterday we spoke about the type of mapping that we have a domain and range. So this becomes my X value and this becomes my Y value. Right. So if I'm talking about this, I'm talking about if I have X1, X2, and X3. Here I get Y1, Y2, and Y3. So this is the mapping that I have for this is my function. So whatever, so I have an f of X in between, a function that maps my X to my Y. So in this case now, if I have this function, what is an inverse? An inverse is a reverse. So we are reversing, basically, we are reversing the function, right? So an inverse is a reverse of the original function, right? So what are we saying? We are saying now, if given Y, what function must we have here so that I can get my X? Because in this case, I have my function X and I'm able to see my Y. I'm able to get my Y using my function. But let's say I'm given Y. How do I find out my X? Because I must be able to interpret both ways. So we're working in what? In the reverse. So now we're going this way. So when it is the inverse now, we draw it again. We have Y1 and Y2, X1 and X2. So now we are going this way. So now we're saying it is the reverse of this function. It is the reverse of this function. So now, if it is the reverse of this function, now I am going this way. So in this case, this becomes my domain now, and this becomes my my range when I'm working in reverse. So here I must have a function that, but I cannot write it as f of X again, because if I write it as f of X again, then it means I'm still using the same function. So I want a reverse of this function. So now the reverse of this function, I write it in another notation. So if I have a function if I have a function f of x, then its inverse is denoted by, it's sort of f to the power negative 1x. This, if you see this one, it means f of x. So it's f into the power negative 1x. So it means the inverse of x. So here, the function that I'll have is a function, is an inverse function. We just call it an inverse function. So the inverse function is the one that is able to map back to the original function, right? So that is our notation. So we want to do an example now so that we'll be able to figure out what do we mean by all of this. Right? Let's do an example of finding the inverse. So the question is, how do we find this inverse? Right? Example. If I have a bracket, a domain here. So this is my domain in this case, which is 1, 2, and 3. 1, 2, and 3. And here I have 4, 5, and 6. And we are saying 1 maps to 4, 2 maps to 5, and 3 maps to. So we are able to figure out that, okay, we are able to figure out that the function here is x plus 3. So the function is x plus what? X plus 3. So now, if the function, so my f of x is x plus 3, it means for me to get to 4, what am I doing? I am adding a 3 all the time. To get to 5, I said 2, I can put a 2 here, 2 plus 3, I get a 5. For me to get a 6, I say 3 plus 3, I get a 6. So I can actually tell that, okay, from here, for me to be able to move from this to this, I must get x minus 3. So if I'm given a 4, I can quickly say x 4 minus 3, I get a 1. I can quickly say 5 minus 3, I get a 2. And I can also quickly say 6 minus 3, I get a 3. So this becomes my inverse function. This becomes my what? My inverse. But this one, it's quite simple. It is very simple because I can actually quickly map out. But normally functions, they not always come in this simplified format, right? They always, we have so many functions that are complex. So we would want to find a generic way of which we can find our functions. So now we are going to quickly now to see how do we find the inverse of a function. So let's write down finding the inverse of a function. This is the shortcut of writing a function, right? So now, step number 1, right? Because you are given your function is y is equal to f of x. So step number 1 is, right, replace f of x with y. Right. So an example, I'm gonna be writing the steps and also writing the examples here. So let's say I have y is equals to 4x, f of x is equals to 4x plus 1. So replace f of x with what? With y. So I'm going to write it now. It's equals to y is equals to 4x plus 1. Step number 2 is replace y with x and x with y. It means I'm just going to, wherever there is x, I'm going to put y. So interchange, actually, let's say interchange x with y and y with x. It means wherever there is y, I'm going to write it as x. And wherever there is x, I'm going to write it with y. So this becomes x is equal to 4y plus 1. Right? Interchange. So it's just substituting where there's y, put an x, and where there's an x, put a y. Step number 3, make y the subject of the formula. Making y the subject of the formula, here we can come and say, okay, I want to make y subject, so it becomes x minus 1 is equals to 4y. Then I divide both sides by 4 and divide both sides by 4. So it means my y is equal to x minus 1 over 4. The last step is replace, number 4. Replace y with the inverse notation. Replace y with the inverse what? With the inverse notation. So now I'll write f of negative 1x is equals to x minus 1 over 4. I am done. This is my inverse. So these are the steps that we are going to be following, right? Number 1, replace f of x with y. The reason why we replace f of x with y is just for simplicity, because it's difficult for us. Sometimes it's not difficult, but it becomes too much work, congested if we use f of x, because sometimes we have f of x inside and outside. So it's better we just replace it with y, which is very simple, or when we use it in our calculations. Now I interchange. That's the next step. Where there's y, I put an x. Where there's x, I put a y. Why? I just want to make y the subject of the formula, right? Then I make y the subject of the formula here. Then I just replace my notation with what? With this one, with the inverse notation sign. So what I'm going to do is I'm going to do another one. Okay, someone is asking, does it count for 4 marks? Not really. It depends on the type of a function. So this is a simple function. Though it has 4 steps, it does not necessarily mean, because sometimes you don't have to all like write it like this. But it depends on the function. If it's a quadratic function, it might be worth 4 marks or even more, even 5 marks. You shall see when we get to quadratic functions, when you're trying to find the inverse of a quadratic function. Let's do another example. Another example. So if I have y, so it says find the inverse. If I have y is equal to 3x plus 4, right? I'm gonna do another simpler example. So I don't have to write all I was writing that time. So I'm just gonna quickly do it. I'm just gonna say, okay, the first thing, this one, I don't have f of x is written as y already, so I don't have to do the first step. The second step is to say x is equals to 3y plus 4. That is interchanging, right? Now I make y the subject of the formula. So it's x minus 4 is equals to 3y, right? Do you see that I've taken the 4 this side, and I'll write it neatly at the end. But sometimes when people try to first write y on this side, they make errors. So it's better to just work out as it is, then you write your final answer in the format that you're required to write it in. Then I'm going to divide all the sides by 3. So I have now y is equal to x minus 4 over 3. And now the final is x minus 4 over 3. So this shows me that I was looking for what? For an inverse. In this case, we are not what? We are not writing the domain in the range. We'll get to that stage. Right now, we're just interested in finding the inverse of this, because this one, the domain, it means x can work anyway. So x is an element of real numbers, right? Now, let's go now. to say, if we draw, I'm gonna now, this is an important concept or important rule, right? Let's write some notes. A function, a function and its inverse. A function and its inverse. If someone is asking, are we allowed to leave it in this form? Not necessarily, because why? If you leave it in this form, I will not understand. Sometimes they will not be able to interpret that this y and this y are different. So you always leave it in this format, which is which I will know that it is an inverse. So a function and its inverse, right, are a reflection about the line y is equal to x. About the line y is equal to what? Is equal to x. So it means if I draw my Cartesian plane, the line y is equal to x is this line. This is the line y is equal to x. Right. That is the line y is equal to what? Line y is equal to x. So remember, when I said y is equal to x plus 4, that was my function. So the reverse of this function is equal to what? X minus what? Minus 4. So let's say 4 is here and minus 4 is here. I can draw this line, and this line will be like this, because my y-intercept is -4. And this one, my y-intercept is 4. So this line is a reflection of this line, right? So a function and its inverse are a reflection about the line y is equal to x. So drawing drawing a line, if you're given an equation, drawing the equation of a line, it's very simple. If you can just plot 3 points or just 2 points on the axis, you can sketch it. So you'll be able to draw that, okay, it's a reflection about, so even if it's a quadratic function, an exponential function, it will still be a reflection about the line y is equal to x. It's very important. And normally they would want to give you a diagram or ask you to sketch a function and its inverse. So the first thing that you must do is you want to see the line y is equal to x. It's very important, right? So this is how we find the inverse of a function, right? And this is how you draw the inverse of a function. If it's a line, it's very simple, but you shall see that later on, when we are given quadratic expressions, we must do something first to them in order for us to find the inverse. So I think this is quite simple. It's not difficult, right? So it is always necessary for you to interchange. Do not forget to interchange here. It is very what? It is. So another thing, this one, I'm just saying negative to the power negative, but it's not an exponent. Are we together? It's just a subscript. This is a subscript. It's not an exponent, right? It's just to denote, right? So that do not confuse it with exponents. It's just a way of just showing you that it's an inverse, not an exponent. So do not try to confuse yourself with that, right? So let's do another one, right? It says sketch the inverse, sketch the function and the inverse and the inverse, right? Sketch the function and its inverse. I'm gonna quickly share my screen right now so that we are able. It says, determine and sketch the inverse of the function and state the domain, range, and intercepts, right? So the function is f of x is equal to 2x minus 3, right? I think we can get back to now. So we need to state the domain, the range, and intercepts. This is the same book that we have always been using. So I'm just quickly taking an example from the book, right? So I'll get back to my screen right now. Right. So the first thing, number one, is to get the inverse. So I'll say y is equal to 2x minus 3. Right. I've substituted. Now it means x is equal to 2y minus 3. I make x minus 3 is equal to 2y. Then I divide both sides by 2 by 2. Therefore, I have my y is equal to x minus 3 over 2. Now I write it f of negative 1x is equal to x minus 3 over 2. I'm done with the first step. Okay, the name of the book I'm using is called Vula. It's an open source textbook that is recommended by the Department of Education. It's free online. You can find it on DBE or you can find it on their website, right? It's called Vula. That's the name of the textbook. Right. Yes, this is plus 3, sorry. Right. So it becomes x plus 3 divided by 2. Right. Thank you for noticing that. Now, we want to now sketch. So sketching is not drawing. Sketching is just getting the important information. So the first thing that I do is I draw my line. Y is equal to x. It is plus 3 here because when we take this to this side, it becomes positive here. If it's negative 3, if we take it, it becomes x plus 3 divided by 2, right? So now, the first one is this one. If we want to sketch this one, I don't know if you are familiar with sketching. If you want to sketch, the first is you get the y-intercept. So the y-intercept in this case is negative 3. And the y-intercept in this case is 3 over, so this one is negative 3. So I'm gonna write negative 3. So I want to see where does it cross the x-axis. So I'm gonna substitute a 0 here. So it becomes 3 over 2. So it becomes 3 over 2. That's where it cuts. If I substitute 0 in this case. So I'm going to say 0 is equals to 2x minus 3. So this becomes x is equal to 3 over 2. So I'm going to put 3 over 2 somewhere here, and I'm going to put negative, right? Then I can draw that one easily, right? So I'm going to draw, this one is the one that I'm drawing because I've found. So I'm going to draw. Sorry for my, right? Then the other one, this one, if I put a 0 here, I get 3 over 2. So I'm going to put 3 over 2. If I put 0 here, I get 3 over 2. Let's say 3 over 2. If I come now and work it out, if I come and say 0 is equals to x plus 3, therefore x is equal to -3. So -3, let's say -3 is somewhere here. So I'm going to draw. So my two important points are the intercepts, right? So can you see that this is my inverse line, and so it's a reflection, if you can see, it's a reflection about the line, and these ones will also intercept. So the intercepts that were being asked here, right? The intercepts are these ones. These are the intercepts. We are clearly showing them on our sketch, and this also is an intercept. So this, what happened to the over 2? This over 2, okay, here, because if I have over 2, if I cross multiply it, it becomes 0, right? Because it's 3 plus x plus 3 over 2. But this 2, if I multiply it by 0, it still becomes 0. So it's because it's just like writing x plus 3, right? Right. So this is our sketch, right? Now, our domain, right? Our domain and our range. So our domain, in this case, what is our domain? This works for everything. So it's x is an element of real numbers. X is an element of real numbers. And in this case, if x is an element of real numbers, it means our range is, we also get our range as an element of real numbers, because whatever number here, whatever number we put here, we get a number. So we get our number from -infinity to +infinity. So we'll write it as an x is an element of what? Of real numbers. Right? So finding inverses of linear equations is very simple. Right? Finding linear finding the inverses of linear functions is very simple, because we don't have to the question the other side, then divide by whatever coefficient we have for y. Right? So now, must the functions cut the line? Yes, they can cut. Like in this case, this one can go this way and this one can go this way. So we are saying what the range. So here we have a function which says 2x minus 3. Right, is so we said x can be an element of any real numbers. Then also y should be an element of real numbers. Why? Because any number that we put here, we get unlimited numbers. Someone says, I don't understand how to get the intercepts. Okay, we'll do it in another example just now. Let me get to another example. I'm just quickly looking for, I want to share my screen right now so that we are able to do this together. This is my screen. Can you quickly note down some of the questions? I'm going to also write them down so that we can do them together. It says, number 1, given f of x is equal to 5x plus 4, find the inverse. Okay, that one is a bit easier, right? So I'm just going to be checking your questions as well. So we have number 2. It says, if we have f of x is equal to -3 minus 7, a is the relation a function? Okay, is it a function? Right. Our most important is want to determine the inverse. Right. Number 3, sketch. Now, this is what we want. Number 3, it's sketch. Well, sketching is important. Sketch the graph of f of x is equal to 3x minus 1. And its inverse on the same axis. This is what we are more interested in, right? Indicate the intercepts and the axis of symmetry. The axis of symmetry, remember, it's our line y is equals to x. So I'm going to do this quickly. I'm going to go back now. So the question that we are doing, we want to start with question number 3. Question number 3 is sketch the graph of 3x minus 1 and its inverse on the same axis. So I'm going to try to draw a bigger, line so that we'll be able to do it together. So let's do the example. So we're doing example number 3, which says we have a function f of x is equal to 3x minus 1, right? And we need to sketch it and its inverse on the same axis. So I'm going to put the axis here. So this is the y-axis, and this is the x-axis. So now we want to find the inverse first, right? So finding the inverse is not difficult. We want to find the inverse. It becomes y is equal to 3x plus 1. So this now becomes, we interchange, it becomes x is equal to 3y plus 1. This goes to the side, it becomes x minus 1 is equal to 3y. Then I divide by 3, then I divide by 3. I will get y is equal to x minus 1 over 3. Then I can write it as in inverse form, which is x minus 1 over 3, right? X minus 1 over 3, right? Okay, I'm just going to quickly share the screen again so that we look at the question again together. Right. The question says f of x is equal to 3x minus 1, right? That's what it says. So that's with x is equal to 3x minus 1. So we have our two equations. This one is f of x, and this one is f, the inverse, which is x minus 1, x minus, okay, yeah, says minus. Okay, so this becomes plus and plus and plus. Okay, thank you for noticing that mistake. Right, so now we are going to try to sketch this one. So the most important line that is important to us, which is our guideline, is y is equal to x. That is our most important line. So now we first find the important points. So to sketch a line, it is easy. You just have to find the 2 points. Wait, they intercept the y-axis and the x-axis. So the first one, let x be equal to 0. If x is equal to 0, it means I'm going to say y is equal to 3 times 0 minus 1, which is equal to just minus 1. So the intercept of this one is -1. So I'm just going to say -1, -2, -3. 1, 2, and 3. 1, 2, and 3. -1, -2, -3. Right? I have written my values on the axis, right? So here, this one, it cuts the x-axis at -1. It cuts at this point. What about when it cuts the y-axis? Let y be equal to 0. So it becomes 0 is equals to 3x minus 1. If I solve this, I get x is equals to 1/3. Right? So now I come. So it cuts somewhere there. Let's say that's where 1/3. I'm just giving an example, right? Where y is equals to 0 and 1/3. So it means now I can now plot by just connecting these 2 points, I can draw my line nicely. I've drawn my line. So you can draw a line by just finding the intercepts. That's what the question is saying. You finding the intercept. So the intercept here is 0 and -1. And the intercept here is, it's 0 and -1. And the intercept here is what? It's 1/3 and 0. That's our intercepts. All right? So now I was dealing with this one. That's what I was dealing with. I was dealing with this one. Now, let me also deal with this one. Right? Now I come. Let x be equal to 0. So if x is equal to 0, then it means that I'm going to substitute y is equal to 0 plus 1/3, which is just equal to 1/3. So my point here is what? Is 0 and 1/3. I come and mark it 0 and 1/3. Let's say 1/3 here. 0 and 1/3. I've marked it somewhere there. And now let y be equal to 0. So if y is equal to 0, I'm going to say 0 is equal to x plus 1/3. But if I cross multiply, I still get 0 is equal to x plus 1. So x is equal to -1. So I have my point, which is what? -1 and 0, which is this point. -1 and 0. So I will now take my calculator. And what? I will now take my ruler and draw. So can you see that it is neatly, I can find my intercepts by letting y is equal to 0 and x is equal to 0, and letting y is equal to 0 and, right? Which is very what? Which is very simple. Now I've drawn my so this is my f of -x, f -1, which is the inverse, and this is my f of x. And you can see that it is a reflection about the line y is equal to x. So that is the main characteristics. You actually get more marks by able, because you can never be able to draw the inverse without first finding the inverse. So if they tell you to draw or sketch, you have to first find the inverse, which you get marks for, and you have to get your intercepts. So this is my intercept, and I got my intercept, another intercept here, and here I got my intercept. I think that was okay. I'm glad someone found his or her mistake. Thank you very much. But this is a basic way which we can use to find our inverse and sketch it on a graph, right? So let's look for another example on our. I'm going to share again. Right. So it means if you are given this inverse, let me just explain another. So say, is it important for them to intersect? Yes, because this is what I want to see. Sometimes they do not intersect. If they do not intersect, it's not a problem. Do not worry yourself. Well, maybe they'll be parallel, like the first one that I drew, where they are parallel to the x-axis, right? The first one that I drew, I'll bring it back. This one, they are all parallel to the line y is equals to x. So they do not intersect. But this one, they do intersect because that is the property that they have. So as long as you can figure out and see that, okay, this gives a sort of a reflection about the line y is equals to x. So it means sometimes you will only be given the inverse. Are you able to find the function? Let's say you're not given the function, you're just given inverse. Then they tell you to draw this inverse with its function. It is the same step because you are now finding the inverse. So the inverse of this one is this. And the inverse of this one is also this one. I will show you just now, right? So if I'm given, right? If I am given f of negative, the inverse is x plus 1 over 3, and I need to find the function. I just still do the same thing. Y is equal to x plus 1 over 3. I interchange. It becomes x is equal to 3y plus 1. It becomes y over 3, right? Now, what do? I cross multiply. Cross multiply, it becomes 3x is equals to y plus 1. Take this to this side because I want to make y the subject of the formula. So it becomes 3x minus 1 is equals to y. Then I can say y is equals to 3x minus 1, which is my f of x. So now I can now find my f of x and now just perform let x is equals to 0 and y is equals to 0. Let x is equals to 0, y, I get my intercepts. I must make sure, please do not omit this y. Put it in dotted form so that you are showing that it's not a line or f of x. It's just a mirror that I'm drawing. So this is very important. So today we have learned about linear equations, linear functions, and how to draw them with their inverses on a Cartesian plane. Right, you must practice. Yes, these are the simplest, and this is what we studied with today. Tomorrow we'll do the quadratic, and the following day the exponentials, which are a bit more challenging. They are not difficult though. It's just a matter of you putting your mind, following each and every step. So I'm going to share the screen again so that you can try to see what is happening. Okay, this is your work which you can do today. Then tomorrow we can try to check out the quadratic functions, their intercepts, and how do they reflect about the line y is equals to x, their inverses. How do we get their inverses? It's quite simple. You have learned of the concepts before. So it's just an extension of what we're going to be doing. So tomorrow, we're going to be learning about quadratic functions. So please tune in so that you'll be able to gain some knowledge tomorrow. So I would like to say thank you very much. I would like to say thank you very much for tuning in. I hope you got some light today, and you are now able to find the inverse of linear functions and be able to draw them on a Cartesian plane. So thank you very much. Enjoy your day.